The picture you see is for a heat engine, which takes in a amount of heat, converts that heat to work, and then discards some heat, QC. And one of the connections we have is that the work done is the change between these high reservoir or hot reservoir and cold reservoir. And we also have that the efficiency is given by the work done over the amount of heat absorbed, which also can be written as 1 minus QC over QH if we use this relationship up here and then simplify a little bit. So in part A we're asked to find the average work, and in part B we're asked to find the heat discharge for working for 1 minute. So the delta time here is 1 minute. And we can say that the work done is not only the change in the temperatures between the two reservoirs, but it's also the power times the change in time. And we're told that the power of this lawnmower is 3 times 10 to the third watts. And if we're working for 1 minute, then that's 60 seconds. Please be careful when you use work and watts that it's not the same letter, right? This work is a physical measurement, where this is a unit. So try and distinguish between those two, please. And if we do this, we get 180,000 watts, or 180 kilojoules, not watts, but joules. Let me fix that. Joule and kilojoule. So now that we know what the amount of work is, the amount of heat discharged, Q sub C, can be written as Q sub H times the quantity 1 minus the efficiency, and that's obtained if we solve this equation over here for Q sub C. And if we know that Q sub H is the work plus Q sub C, I substitute that into where QH is, that gives us that QC equals, we're going to FOIL this out now, so we're going to have the work W minus the work times the efficiency plus QC minus QC times the efficiency. And if we solve for QC from that expression up here, we get that it's equal to W times 1 minus the efficiency over the efficiency. And plug it in the values that we know. We know that the work is 180,000 joules. 1 minus the efficiency, we're told, is 25%. So 0.25 all over 0.25. That gives us 540,000 joules, or 540 kilojoules. And you notice that the amount of heat discarded is much more. It's triple the amount of work done. So that's something we're going to see often in these examples, which is the fact that the work done is not close to what the amount of heat absorbed, and that's why you see efficiencies in the low 20s. That is absolutely normal for a lot of the stuff that we encounter in our daily lives. Our cars are up in the 30s, I believe. Okay, this ends number 1.